And then okay, continue on. At the end, you should be able to know the name of each element, the physical property, chemical property, and also the trend. What do I mean by trend? What I mean is what happened to melting point and boiling point of the element as we move down across the period. What happened to the reactivity? Okay, maybe what happened to the density, and so on. This is called a trend. Okay, of course, you have to memorize certain chemical reaction and what is the observation. So for group one is actually called alkali metal. Okay, alkali metals. They react with water to form alkalis. Okay, so what we have here, we start from lithium. We skip hydrogen. So we start from lithium. We have lithium. What is Na? Anyone?
Sodium.
Sodium. Then we have what? K. What is K?
Potassium.
Potassium. Rb. Rubidium. Cs. Calcium. And Fr. Francium. Okay. Let's have this. So this is the electronic configuration. By now you should be you should know how to determine the electronic configuration based on the periodic table. Okay, so 21, 281, 2881, 281881. Okay, how do we get this 18? Sidetrack a bit. So rubidium, where is rubidium? First of all, I need to locate. It is over here. So it belongs to period 5, right? That means it's supposed to have 5. Okay. First shell. Second shell, 8. Third shell, 1, 2, 3, 4, 5, 6, 7, 8. But here, third shell is what? 18. Why? Anyone? Anyone?
What was the question again?
We see the electronic configuration of rubidium is 2, 8, 18, 8, 1. How do we determine this? By just looking at the periodic table. Okay, let me write here. 2, 8, 18, 8, 1.
The period.
Okay, from period we know that, yeah, yes?
There's 5 of
It is at the 18.
How do we know 18 is the third one? Why not the fourth one?
Because of the formula.
How do we
Because it
determine?
can't hold 18. I don't know.
Actually, right, this part of transition element, right? Where do you think the electron goes to? The third shell or the fourth shell? Actually, this one, the electron goes to the third shell. So for example, rubidium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This is the electron at third shell. Although it is located at the fourth period, okay, but it just happened that at fourth shell, right, when you have 2 electrons, the third electron will start filling out the third shell again. Okay, so total, the third shell will be you have 18. Well, just sidetrack a bit only. I think it won't ask this kind of question, so don't worry. So what are group 1 elements? As I mentioned, it is I'm going to type here.
Alkali.
Group 1. It's called alkaline metal, right? Remember, it's not just alkaline, it's alkaline metal. So group 1. It is alkaline metal. Hold on. Alkaline metal. What is the appearance of group 1? Physical appearance. It is a gray solid with silvery surface when freshly cut. Now it quickly turned down due to oxidation that happens. It is oxidized by oxygen in the air. So it is only when it is freshly cut that you can observe silvery surface.
You spelled surfaces wrong.
Okay. Then they are also very reactive, highly reactive. That's why normally when you get these group 1 elements, it is coated with what? Anyone can answer.
Wait. What was the question again?
It is highly reactive. That's why when you obtain these chemicals from the chemical company, normally it comes it is coated with paraffin oils. So it won't react with oxygen and also water, the moisture in the atmospheric air.
Okay, but the book said mineral oil.
Paraffin oils is a mineral oil, I think.
Are you looking at year 9?
It's the same
or year
thing.
8?
It's the same thing?
Huh? Hello?
Paraffin oil. Let me check. Liquid paraffin oil is a type of mineral oil, so actually it's the same thing.
Okay.
Yeah. So now the physical property. It is very light. Or have low density. Okay. In fact, they float on water because they have a lower density than their density is lower than water. They refer to lithium, sodium, and potassium. These three elements have a density lower than water. Okay. What is the second physical properties? It is soft. It can be cut with knife easily. How about the third one? The third one is they have a low melting point and boiling point.
Wait, isn't it high melting and boiling point?
If you compare across the periodic table, it is high, but when you compare just with metal, it actually has very low. In fact, I think it's the lowest among the metals element.
Okay.
So if you compare with other metals element, it is very low. But if you compare with let's say the non-metal like group 7, then you can say it's very high.
Okay.
Now, this is the physical property. What is the trend? Trends in their physical properties. Okay. We look at the trend as we go down the period, across the period. So from period number 2 to period number 7, we're going to look at hardness. We're going to look at melting and boiling point. We're going to look at atomic radius. We are going to look at electronegativity. We're going to look at density. Okay. Trend in their physical property. Hardness, melting point, boiling point, atomic radius, electronegativity, and then density. So if we move down from lithium until francium, from period 2 until period 7, what happened to the hardness? Anyone? So in other words, lithium is the hardest or francium is the hardest among group 1?
Francium?
Francium.
Francium is what? Hardest? Or
Lithium is hardest.
lithium is hardest? Let me
Lithium?
see. Lithium is hardest. Yes, lithium is hardest. So as we go down
Yes.
from period 2 to period 7, right? The metal becomes softer and softer. So here I put a arrow. So hope you understand.
How is lithium hard? Isn't it the lightest?
It is the lightest, but the density doesn't determine the hardness. Does not determine the hardness. I think francium is the softest one because of its radius, atomic radius. Because it is so far apart between each other that it is not hard. Yeah.
Okay.
So for melting and boiling point, what happened as we move down across this period? It increase or decrease?
Increase?
No, actually it decrease. Okay, both melting and boiling point. So lithium has a highest boiling point and melting point. While francium has the lowest boiling point and melting point. Now, atomic radius, it is very easy. As we move down the period, of course, we have more electron shell and the nucleus is bigger. So our atomic radius increases, right? Electronegativity. What is electronegativity? Anyone? Electronegativity.
Uh, is a measure of the tendency of an atom to attract a bonding pair of electrons.
Tendency of an atom to attract one electron, right?
A bonding pair of electrons.
Okay. So as we move down the group, what happened to electronegativity?
Decreases.
Yes, decreases. Actually, this element is electron positive. Electropositive. It means they form positive ions by loss of one electron. So, yeah. Move on to density. For density, what happened to the density as we move down the group, the period?
Increases.
Increases, correct. So you need to understand this trend. So far, any question? Yes, EB, any question?
Nothing.
Okay. Hold on, yeah. Melting point, blah 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 blah. Okay, melting point and boiling point is slow. It decreases as we go down the group because the size of the atoms increases as we go down the group. As a result of which the interatomic forces between atoms decreases and a small amount of heat is required to overcome the metallic bonding force between atoms. So as the atomic radius increases, the distance between radius also increases. That means between atoms they have weaker force holding them together. That's why the melting point and boiling point decreases. Okay. Let's look at the chemical property. So for chemical properties, what kind of properties are we looking at? We look at reactivity. How easy it is to react with other metal. We look at what else? I think that's all. Reactivity. Then we look at each individual, how each individual chemical reacts with water. So as we move down the period, what happened to reactivity? Increase or decrease?
Decrease.
Decrease. No, it actually increased. The reactivity increases down the group. Let me explain why is it so. Okay, so for lithium, it only have 1, 2, right? But for francium, 1, 2, 3, 4, 5, 6, 7. Okay, so I will not draw every electron here, take too much time. So I just draw the valence electron. Okay, the distance between nucleus and the valence electron, which one is nearer?
Lithium.
Lithium is nearer, right? This is the distance. Or for francium,
Further.
Very
it's
far.
furthest. It's the furthest. So actually, how this electron stay in its place is because of force of attraction of proton, which is positively charged inside the nucleus, right? So the shorter the distance, the stronger the force of attraction. Yes? Can you follow? Okay, understand? The shorter the distance, the greater the force of attraction. Which means when you compare lithium and francium, which one lose the electron more easily?
Francium.
Francium, right? Because it is furthest apart from the nucleus, so it lose the electron easily. So a reaction happens when francium loses electron or receive electron, but most of the time francium lose electron. Okay, I think most of the time group 1 element lose electron because they are electron donor. They lose electron to achieve a stable atom, right? Stable ion, whatever you call. So this is the reason why the reactivity increases down the period, across the period. because as we move from period 2 to period 3 to period 4 to period 5 and to period 6, the distance between nucleus and the valence electron is increasing also. So the force of reaction decreases. It reacts more easily to other elements. Now, elements in the same group, they have same chemical properties. They react with the same thing, just with different reactivity. So I will not go through, but when you go back, please study the reaction of group 1 element with water. You should at least memorize or understand the observation of it, and also what is the end product. I'll just give one example here. Okay, so reaction of group 1 element with water. So how you do is actually you cut a small piece of metal and put it, scrape off the oil and put it in the water. Okay, so the result, okay, I will upload another photo. This will be the result. Okay, so for lithium, it moves slowly on the surface of water. A soft heat sound is produced, and a colorless solution is produced, which turns red litmus paper blue, showing it forms an alkaline solution. Heat sound heard is due to release of hydrogen gas. So this thing is very important. It will come out in an exam. I will not go through every element. So it is for you to go back and study. Okay, understand? Nobody responding.
Understood.
Oh, Kenneth.
Yes.
Hi, Kenneth.
Hello, Kenneth.
How are you? Feel sick? Are you okay?
Play game, every day play game ah.
Because you stay out whole night, is it?
Liana, I'll kick you.
all right. Okay, so for group 1, any question?
Yeah.
This pretty sums up everything that you need to know. And also, you need to go back and who is that? Kenneth?
Yes.
Kenneth, you're really not feeling well.
Yeah. Why would I lie?
Corona.
Last straw, I'm gonna kick you soon.
Is Kenneth host?
No, I'm host.
But okay. All right. So we move on to group 7. If you don't have any question, we move on to group 7.
Okay.
Okay, group 7, what is the objective? Lesson objective is the same. You need to know the names of each element. You need to describe the physical properties. You need to describe the chemical properties, and also you need to understand the trends in the behavior of group 7 elements. Name, physical properties, chemical properties, trend. Same thing will happen in group 8. So for group 7, is this one. Wait, let me change to black pen. This is group 7. And we have what? Can someone name each of the element?
Fluorine, chlorine, bromide, iodine. And then I don't know.
What is AT? Astatine. Astatine. Sorry, I think 117 is not included in the group, so it only be this. Okay, fluorine, chlorine, bromine, iodine, astatine.
Astatine.
5. Okay, for this one, lithium, sodium, potassium, rubidium, cesium. What is this? Calcium or what? Calcium. I think it's calcium. And then
Maybe.
francium. Caesium. Sorry, caesium. CAESIUM. Or CEASIUM. Caesium. Now make sure you memorize the name. Yes, C? C what? CAE or CEA?
CAE, I think.
CAE.
Yeah, CAE.
Depends how you pronounce it. Some pronounce cesium, some pronounce caesium. Depends how you pronounce it. Okay, let's focus on this halogen. Okay, halogen. Halogen will have hold on, yeah. Okay, this one. Okay. Halogen. This is their name, their symbol, and their electronic configuration. Okay, notice the difference. Let's say we take group period 5. Okay, and compare it to period 5. Oh, sorry, this is period 6. Yeah, actually this is the period 5. 3, 4, 5, 5, this one. Okay, for rubidium is 2, 8, 18, 8, 1. 2, 8, 18, 8, 1. For iodine, 2, 8, 18, 18, 7. Do you notice the difference? Anyone?
Yes.
They both have 7 valence electron.
Valence electron difference. What else? What else is different here? It's different here.
One need to take away one.
What the one is 8, one is another one is 18.
Yeah, this one. Okay. So just need to take note lah. I think just need to take note about this. No point I explain it now. It involves A-level chemistry. So
Complex.
yeah, it studies the different types of electron shell. Apparently there are many types. you will not learn this in your IG. But okay, move on. So this is group 7, also known as halogen. They are metals or non-metals?
Non-metals.
They are non-metals. Okay. Are they reactive?
Yes.
Yeah.
So let me add.
Mm.
So put it back. All right. So first of all, it is known as halogen. It is a non-metal. They are quite abundant and can be found in Earth crust as metal halides and mineral salts in seawater. Okay, so it naturally exists as a metal halides, which means metal plus halogen minus metal halide. It's a ionic molecule. Okay, and or mineral salts. Mineral salts is also metal halides. For example, sodium chloride. Anyone of you know what is sodium chloride?
Yeah.
Okay, table
No.
salt. Sodium chloride is actually considered a metal halide. It is also a mineral salt. So it naturally exists as a metal halides or mineral salts. These elements are diatomic. They also exist in the form of diatomic. What is diatomic?
Of 2 atoms each.
So for example of diatomic is like this, where they share,
No, that is 2, right?
yeah, 1 atom, 2 atom, diatomic. So for example, chlorine gas, okay, chlorine gas or bromine gas, so on. Okay, diatomic. They are highly electronegative. So we now move in the highly electronegative means it is very reactive in receiving electron from other atoms. Okay, so electronegativity decreases. We'll look at the trend later on. We first look at the physical property. Melting point. Melting and boiling point. Then atomic radius. And electronegativity. And then density. Okay. So for melting and boiling points, what is the trend?
Increases down the group.
It increases
Down the group.
the group. Increases down the group. Same thing happens for boiling point. How about atomic radius?
Increases.
Atomic radius always increases down the group because they have not down the group, down the period. Because each period you have an extra one electron shell. Now for electronegativity, when we go down from period 2 to period 6, what happened? The electronegativity decreases. Okay? Density increases. Okay, we also like to look at the state of elements. So for group 1, all the elements exist in the solid state. But for group 7, not all exist in solid state. For fluorine, it exists as what? Gas, right? Gas. Bromine exists in liquid form. Iodine acetate, solid. Okay, this one you need to memorize. No choice. And also one more about physical properties is this. Color density or color. So as they move down the period, what happened to the color?
Becomes darker.
Yeah, darker. Okay. I think it's important for you to memorize. A lot of things to memorize lah. No choice. So for fluorine, it's yellow in color. For chlorine, yellowish green. Bromine, reddish brown. Iodine, purple. Astatine, black. Okay. So this is the trend lah. The general physical property of sickle. It has a low melting point and boiling point. Because the molecules are held together by weak intermolecular force called van der Waals force. And only a small amount of energy is required to overcome the weak forces of attraction. That's why it has low melting points and boiling points. For the first two elements, it exists in a form, in a gaseous form, fluorine and chlorine. Hence, they have very low density. Okay, and they are non-metal, so do they conduct electricity? Yes, no? Non-metals, do non-metals conduct electricity?
No.
No. Except
No.
for
Except graphite. Graphite,
Yeah.
right?
Yeah.
So they are not conductor of electricity. electricity, and also weak conductor of heat. Okay. Then we move on to chemical property. All halogens have similar chemical properties because they belong to the same group, but the reactivity varies. Rate of reaction differ. So reactivity. Okay, first of all, it is a electron receiver. Okay, in a sense, it receives electron most of the time. Now, as we move down the period, what happened to reactivity? Anyone?
What's the question again?
As we move down
Weaker.
the period, what happened to the reactivity? So you
Okay.
do comparison between fluorine and also the last one, which is
Weaker.
astatine. Weaker?
They're less reactive, right?
Less reactive. That means the reactivity decreases. It is completely different if you compare with group 1. See, group 1 chemical properties, the reactivity increases. But chemical properties for this one decreases. So I have explained to you why for chemical properties for group 1 increases down the period. Now I'm going to explain to you why the chemical properties decreases down the period for group 7. So group 7, the reactivity is based on how well it receives electron. Because it is an electron receiver, right? So it means most of the chemical reaction, it receives electron. Now let's compare fluorine and also astatine. Astatine is AS, I think. Is it AT? Astatine. AT. So fluorine has only one G2. Two. You have 1, 2, 3, 4, 5, 6, 7. 7 valence electron. While for AT, how many? It belongs to which period? AT, period 6, right? That means it has 6 electron shell. 1, 2, 3, 4, 5, 6. Okay. So the valence electron is always 7. 7. Okay, it also got to deal with this distance between the electron, outermost electron, and the nucleus. So in this case, the outermost electron and nucleus, which one the distance is the shortest one? Fluorine, right? Fluorine have shorter
Yes.
this
Distance.
distance. So if it is an electron receiver, that means it needs to attract one electron, correct?
Yes.
So which one has a stronger force of attraction? The shorter distance one or longer distance one?
F.
Okay.
Sorry?
Fluorine.
Fluorine? I heard fluorine. So fluorine has stronger attraction force, correct?
Yeah.
Because the distance between the valence electron and also nucleus is the shortest. Which means it receive electron more easily compared with this astatine, correct? Agree? Can you
Yes,
follow
sir.
the theory? Because of the distance, this have a
Yes.
stronger force of attraction, which means it receive electron easily compared to astatine. So this have a higher reactivity compared to this one due to this property, this theory lah. So understand? Anyone don't understand?
Yes.
If you understand, then lastly, you look at how each element reacts with other chemical, which is in your edu sheets. I will not go through with you that one also. So you have to go back and study and memorize. Now, so far, any question on group 7?
No.
No?
No.
Okay. So, group 8. After this, we'll end our lesson today. So, group 8. Group 8 consists of this. How many? 1, 2, 3, 4, 5, 6. 6 elements. So, can you name each element?
Helium.
Helium.
Helium, neon,
Argon.
argon. What is this?
How to spell it? That one. And then, yeah, I don't know.
What is this?
Radon.
Krypton. How to
Krypton.
read? Like
Is it
krypton? Yes.
krypton?
Helium, neon, argon, krypton, xenon, and radon.
Radon, correct. Okay, so memorize. And then we are going to look at the valence electron. This one. Okay. Oh, sorry, this is halogen. This one, yes. Okay. So helium, neon, argon, krypton, xenon, radon. This will be the electronic configuration for each of the elements stated. Let's go straight to. Okay, first of all, it is also called as noble gas. Do you know why? Noble gas or inert gas?
Huh?
Because why is group 8 called noble gas or inert gas?
Because they're stable.
Yeah, part of the reason is because they are stable.
They don't need extra atoms or they don't need to take out atoms.
Mm-hmm. Yeah, they because they don't react with another element, so they act as if they are very noble. They are the noble one, inert one. So we call it noble gas. Group 8. Is also called as noble gas or inert gas. So for this one, you not only need to know the physical property, the chemical property, and the trend, you also need to know the uses of each of the gases. But it is an easy one. So the trend for physical properties of physical properties. Melting point, melting and boiling point. What else? Atomic radius, density. Okay, I think that's all. Because it doesn't have any electronegativity. It is a neutral element. So we will not compare that. So for melting and boiling point, what happens as we move down the period?
It increases.
It increases, correct? It increases. Oh, let's have that kind. Increases. Atomic radius always increases down period. How about density?
It decreases. Wait, no. Atomic radius decreases, right?
No, it increases.
Oh, okay.
It always increases down the period. You see, it never changes. Atomic radius increases for group 1, increases because you are adding another layer of electron shell, so the radius will increase. Okay, how about density?
Decreases.
Increases.
Everything in group 8 increases.
Yes. Actually, everything is in group 7 also increases except electronegativity. But for group 1, almost everything decreases. No, actually, it's melting point, boiling point, and electronegativity decreases. But atomic radius and density increases. So density and atomic radius always increase down the period. Okay, it's the same for group 1, group 7, and group 8. Density and melting point, atomic radius. But melting point and boiling point, group 1 is different if compared with group 7 and group 8. But you can do comparison when you have own free time. Yeah, so all group 8 exists as a monoatomic gas. You know what is monoatomic gas?
Monoatomic means one atom.
Yes, one atom. Compared to group 7, group 7 is diatomic gas. That means if it is in its gaseous form, it always have 2 atoms in one molecule of gas. While noble gas, we won't say it, we won't consider it as a molecule. It is atomic. Okay, because remember,
Okay.
molecule is more than one atom. How do I adjust this? Okay. So why melting and boiling point increases? It has to do with the intermolecular forces as well. Density. Okay, now chemical properties of noble gas. What is the chemical properties? Inactive. It is not reactive, so it is inactive. Or we can say it is inert. Because it has 2 or 8 electrons, which make it very stable. Yeah, that's why they do not accept, they do not donate, or they do not share electron. So what is the uses of group 8 element? First of all, helium. What's the uses of helium? Anyone? Helium is used to fill weather balloons. Okay, so all those floating balloons that you can buy in the market is actually filled with helium gas. Because helium gas has lower density than atmospheric air, that's why it floats. Okay. And it is inert gas, so it is non-flammable compared to hydrogen. Hydrogen is highly flammable, so it is not advisable to use hydrogen. It's also used as artificial atmosphere, whatever. Using thermometer to measure low temperature.
Wait, divers breathe in helium?
No, they are not breathing helium. Let's see. Let me check how helium is used in divers. Oh yeah, they are actually breathing in helium.
Is that safe?
Well, it is inert gas and it is not radioactive, so I guess it is considered safe. As in you
Okay.
won't get any poisoning from that. Apparently
Okay.
they have their reasons as why they mix helium inside the oxygen tank. They mix oxygen. So normally their breathing tank, right? They have oxygen, they have nitrogen, and they have helium. It is
Okay.
usually used in a very dyes instead of air. They use this this mixture of air. So you can study it online lah, if you want to know more about it. But yeah, they breathe helium.
Okay.
So what else? Protective atmosphere for growing okay. Many times it is used as protective atmosphere because it is inert. So sometimes when you are doing using a material which are very reactive, this can act as a protective atmosphere. So for neon, neon is used to fill advertisement light bulbs. It is also used as a indicator like argon, used to fill electric bulb because it is inert. So as usual, as what I've explained just now, tungsten filament, your tungsten bulb, right? The tungsten filament is very reactive and it tends to oxidize by oxygens in air. So what happens is they fill the bulbs with this argon gas so that it will not react with oxygen to oxidize. Fill electric bulb. Also produce an inert atmosphere for welding. Up to this point, it is not reactive, radioactive. So it is still safe to be used as a protective atmosphere. Krypton is used to fill high speed photographic flash bulb. And it is used also in lasers to repair retina. Okay, use medical uses. Xenon used in electric tubes and stroboscope lamps. Probably also to prevent it from oxidation. Bubble chamber. Okay, last one, radon. Radon is radioactive, although it is inert chemically. It is radioactive, so it is used to treat cancer patients. Okay, that's all. Any question?
No.
No? We will end our class today here. So